Hello everyone, I'm Chang Guo. LC nickname is GCB. I have been working on Openstack for 6 years. I was the Oslo BTL for release Pike and Queen. This is my college.
Hello everyone, this is Bibin Hong from EasyStack. I currently work for the QA and the DevOps part in our company. Thank you everyone.
Yeah, today I would like to introduce the product from EasyStack, ECS Stack. ECS means EasyStack Cloud Service. Let's see the agenda. First, a short introduction about EasyStack. Then we dive in the product itself, including the core design idea for product and architecture. Then the third part is the demo, live demo. EasyStack was founded in 2014 in China. The core engineering team were from IBM China Research and Development Center. In last week, we just announced the Series C+ round with 3 million RMB, equals about 60 million Canadian dollars. We have provided products and service for more than 300 enterprise customers like China Mobile, China Telecom, Lenovo, Tsinghua University. We sponsored each Openstack Summit since EasyStack was founded. We are the EasyStack is the gold member of Openstack Foundation, the silver member of the Linux Foundation, and the member of the CNCF and other open source other open source organizations. EasyStack love open source. We also upstream actively. Currently, we have 1 people as the individual board director, 1 project team lead, 5 core reviewers in Oslo, HIT, Sahara, Chow, Telemetry. In 2016, the Gartner report says the Hyper Converged integrated system will be the mainstream in next 5 years. Also, I cut HCI grows faster in recent year. More and more companies invest on it. EasyStack think the chance of the HCI should be from hardware infrastructure abstraction to software infrastructure abstraction. Second, from resources oriented to application oriented. Then it can be management by multi-cloud, and the architecture should have the capability of sustainable evolution. Let's see the core design idea for the product from the user's view. First, the product should be simple. It can be easily install and use it without rich cloud experience. Then, the system should be reliable. That means we can reduce the workload for the operators. Third, it should be easy to use from user side. And the last, it should be upgraded smoothly online with 0 time to keep the business workload running. From the side of the core design idea for architecture, it's based on microservice, so it has all the benefits of the microservice. It's designed for node failure, means each node can fail, but can't affect the business. Third means full symmetry, means each node have the same role. It's different from the traditional role like a control node, compute node, or storage node. That means each node can be easily replaced by another one. The fourth is the event-driven. Yeah, we provide an event system named event mesh. It can receive the trigger event and take action. For example, if we found one of the node disk is full, it can be do the cleanup automatically. Let's see the product architecture. At the bottom is the hardware infrastructure, the server node and the networking device. Up that is the distributed microservice architecture that can make the product can be upgraded online. Then there are the common services like the compute service, storage, networking, and the management security service. The most important part is about the common service is the perceptive visual orchestration service. My colleague will demo the function later. So the above part is application-oriented. We also have the service for the monitoring and operating. The event mesh I just mentioned. There is a service to back up and disaster recover. The service can back up the volume of instances in different data center. If one data center down, we can also bring up the instance or volume in another data center. But there are also the monitoring and alarm system to detect the failure and send out the email. So let's see the demo time.
OK, thank you, Changbo. And welcome, everyone. I'm Binbin Tong, and I will give you the live demo. Hope nothing crashed as the keynote yesterday. OK. As Changbo introduced, we have perceptive visual orchestration. So for the perceptive visual orchestration, I will demo one scenario. This scenario, I will create several instances with several volumes connected to their private network, routers, and the public net. Then I will create a load balancer to balance the load for the two instances I created. And for the second demo, I will focus on the application center. The application center is our main focus in our product. I will import the visual orchestration into the application center and show you how you can create the app how easily. OK, let me switch to the web browser. This is our platform. Sign in. A little bit slow. OK, the resolution is slow, so I hide this one. Go to the orchestration stacks. Then we can create a template. We can create from scratch and then create. You can see from the left side, I can see get the public network, shared network, private network, including routers, floating IPs, the compute and the storage resources, including instances and volume. And we have the load balancer. Then I will create an instance. Let me just drag and release. As you can see, the dependencies for this server are also created. The public net connected, the router created and connected, the private network also created and connected, and the server. We have to specify the password here and confirm. Then I will save it. So right now we have one server. Then I will create another one. As you can see, the private network is highlighted, and the others are gray. This is called perceptive orchestration. So I release the cursor, and it will go to the private network. And also, we need to specify the password. OK, then, as I said, we will need some volumes. As you can see, the volume can make the server 0 and server 1 to be lighted. Which one is the closest to the volume will be lighted. And release cursor, it will go to server 0. And another one go to server 1. Will be fine. OK, servers volumes are ready. Then the load balancer. Drag load balancer, and the private network 0 is lighted, release, and we get load balancer. I'll be listener, and sorry, the resolution is a little bit low. For the listener, we need to specify a port. Let me say 23. Save it. Then let me go to the LB pool. And we need to add the resources, server 0. Let's say it's Apache application, it's 0, and weight to be 1. And another resource, server 1, also 80, and weight 11. Save it. You can see the topology, the LB pool connected to the server 0 and server 1. OK, this is the template. I need to save it to be demo 3, maybe. Save it. And wait a little bit. Oh, it's created successfully. Go back, and you can see the demo 3. Then I can deploy this template. You can see we have resources, routers, private networks, instances, and so on. We specify a name, demo 3, and deploy. Just 1 second. OK. The deploy is in progress. It will take some time, so I will just switch to the scenario 2, another browser. And we will go back to that one later. I will specify admin user, sign in. Slow. OK, go to the console. Also, the orchestration stacks. For the import to application market, I will need to create the template first, also create from scratch. Let's say I need a Tomcat application. I will need instance, also router, private network. I won't change the settings. And the server 0, I will need to change the image. Tomcat. Select. OK, OK. Sorry. OK. OK, I select the Tomcat and the flavor. Maybe 2 vCPU, 4 GB memory, and 40 gigabyte disk, and select flavor, specify the password, specify add test, then we can save it. And now for the application, normally people will like a floating IP to connect to the application, so I will add a floating IP to the server. OK, it's done. Let's save it. OK, maybe demo 4. In this forum, I can also import to the application market in just one step. Save it, create it, and then I will go to the import to app market frame, specify a name, demo 4, 5, OK. Category, tag, maybe Tomcat. Description, Tomcat. Author, EasyStack. Then I will go to the next step, deployment information. This is the application version. I will say V1. Description, Tomcat. Notes, Tomcat. This one is at the application access. It means if I add this one, the application will expose a public interface to be accessed for the user who deployed the application. This is the instance to select 01, server 0, and we need to use the floating IP to access. And Tomcat use the 8080. OK, so we can import it. Then we go to our applications. As you can see, the demo file is here. So with just several clicks, I created a Tomcat application. And the users can deploy the application from here. View details. You can see discrete descriptions, versions, author, tag are here. And we can install the demo file v1 version. Just the name, demo file. Version v1. The password will be got from the template test. Server 0 flavor, 2 vCPU, 4 GB memory, and 40 GB disk. Also, the network configurations, you can see, are all from the template I created before. Then install it. You can see the demo file is deploying. Let's go back to this scenario 1. This one will take some time. Back to this one. It's deployed completed. Let's check the resources we created. The instances. OK, server 0, server 1, demo 3, and volumes. Demo volume 1, demo 3, volume 0, and the load balancers. Demo 3, load balancer, listener, pool are all there. They are all created with just several clicks. Let's see if the deployment, OK, it took some time. OK, it's active now. I can view the details. This is the node information, the server 0 I created. The status is active, and the quick access is there is a floating IP I created, and the port is 8080. Description is Tomcat, and status active. OK, thank you. This is the demo. Thank you, everyone.
后边有。
And go to the next slide.
Yeah.
Maybe next one. Next up, we will have a DevOps session in room 301 tomorrow afternoon. And welcome to visit our booth at C1. Thank you. Thank you. Just there.
Thank you.
Thank you.